Hello everyone and welcome. Thank you for joining us. I'm just going to wait a couple more seconds to see if there's any more people to join, and then we'll make a start on safer insect trap lighting for food sites. Okay, I can see we've got a good amount of people joined, so I think I'm going to go ahead and make a start. You will get a recording at the end of this, so don't worry if you have missed anything or there's something that we haven't quite covered that you wanted to ask us. You'll get the recording at the end and chance to ask further questions. So first, I'd like to introduce your speakers. I'm Jasmine Emerson, Sales Director at Opti-Catch. I'm joined by Stuart Dell of Signify and Kim Stillwell, who is Technical Manager for Food at BRCGS. You'll get to know a little bit more about us as the presentation goes on. So what we're going to cover today is first and foremost the RoHS directive, specifically the difference in legislation between general and special lighting, because that's quite an important differential to understand. We're going to cover the timescales for an exemption extension and also what needs to happen before a fluorescent ban can take place. We'll then touch on the benefits of retrofit LED and what you should really take into consideration before you switch. We'll finish with the opportunity to ask questions to the panel. And as I say, if there's any that we don't get a chance to answer, we will follow up with you afterwards. So I'm actually going to hand over to Stuart now from Signify so he can cover the RoHS portion of the webinar.
Thank you, Jasmine. Right, I'm Stuart Dell. I'm from Signify. You might better know Signify as Philips. So we were formerly Philips. We broke into Signify in 2018. So we've been 7 years, just rising our 8th year as Signify. We are the largest lighting company globally, and we're one of the largest light source manufacturers specifically for electronic fly killers. So just to put a little bit of context around who Signify are. My aim is to share with you RoHS and to share with you what RoHS is, what RoHS and how it impacts the electronic fly killer area. I put it down in a very crude way. So no more fluorescent lamps in EFK after 2027. Sort of who the hell told you that? I don't know where you stand. I don't know what information you've had fed to you. But at some point you might have come across somebody saying to you, oh, well, after 2027, I won't be able to purchase fluorescent lamps. Well, I want to put the truth around this situation and put some reassurance into you of the RoHS process, and so you understand and can take a decision as your own business against realities. So where might you have got this information from? The reality is that so I've realized my slides are blocked, right? The reality is you may have got it from somewhere like Google. This was yesterday. I put a question into Google. Are fluorescent lamps now illegal? And you would be forgiven for taking the Google information that says, yes, they are. So as the CEO of Google said to us just back in November, he said, do not blindly trust everything that AI tools tell you. So in this instance, please do not blindly trust them, and I'll explain the process and I'll explain why you are not to blindly trust them and give you knowledge so that you have some understanding of the process and can take your own decisions as a business. And I know I've repeated that statement, but it's really important that you take control of what you do as a business. So a little bit of background on RoHS. Restriction of hazardous substances. So that's what RoHS means. It's been around actually for 23 years. It was first adopted in 2003 by the EU. It came into effect in 2006, specifically looking at 6 substances within the electrical industry. For the lighting industry, mercury was the key substance that RoHS impacted us. So an awful lot's happened in those years, but it was in 2023 that maybe people really started to see what RoHS was about, because in 2023, white light linear and white light compact light sources from the visible lighting spectrum, so that is lamps that you put into a space that light the space, they were banned for sale in the EU and in the UK. So it's fair to say you can see where Google and other AI tools and maybe people with only limited understanding and knowledge of the process get their information from. But the fact is that fluorescent lamps for special applications are not affected by this 2023 light ban. So that's just a simple statement to fully understand. They are not affected. I will now explain what special applications are so that you have an understanding. This is really important to understand that these three cross each other, because in the slide that follows this, I will explain how they cross. But there's the special lighting applications go either side of the visible light spectrum. But specifically, the spectrum of insect trap goes into the UVA side of the spectrum. So UVA covers 400 to 320 nanometers. UVA for special applications, the types of applications we're referring to are insect traps, clearly that's why we're here, but UV curing and reprographic. So it's used within the reprographic printing industry. UV curing, it's used for contact lenses, for example. So if you wear contact lenses, it's highly probable that in the process of manufacturing those lenses, UVA has been applied. Then you move to UVB. UVB is psoriasis. So if you are unfortunate enough to suffer with psoriasis, or you know somebody who does, and it's a full body psoriasis, they will be exposed to UVB lamps as part of their treatment regime. It can also be used for tanning beds, for suntan beds. Then you move into the UVC spectrum, and this specifically focuses on nanometer range 254, between 290 to 200 nanometers. UVC is purification. So this is purification of air, purification of water, surface disinfection. So UVC, there'll be areas that UVC is used where you'll not realise. There's a large part of our country where the drinking water that we use, that we drink, that you turn your tap on, has seen UVC at some point in the process of you turning your tap on and receiving that water to then drink. So it's really important to understand how these three are all special applications. And the reason I highlight all three is because RoHS categorizes lamp types, and there are many, many categories. This is just one slide. Actually, I could put a second slide on which shows the same again in categories. And these categories are all categories of applications. They can be from lamps for entertainment. They can be lamps for infrared use. They can be lamps for UVA, B and C. But specifically, let's home in on the two categories that are relevant to our industry, the insect light trap industry. There are two categories that RoHS has identified and has collected together. It's really important to recognise that they are collected as UVA, UVB and UVC. So all of the applications I have previously mentioned are collected in these two categories. So you have category 1F1 and category 2B43. These two categories, the first 1F1 is for compact light sources. The second is for linear light sources. Moving to my next slide. With these categories, RoHS is about understanding that the EU look at these categories. They give these categories a 5-year review period. So the date of February 2027 is purely a date for review. It's not a date for ban. So the reason it is dated as February 2027 is because the last review was completed in February 2022. So under the governance of the EU, they will not extend these categories by more than 5 years. So given that it's just a 5-year extension, in 2027, the EU will revisit these categories and will make a decision whether they are going to allow the continuation of manufacture or whether they will actually go ahead and ban. Now, the way that the EU work is they don't come knocking at the industry's door. They do not come knocking at the lighting industry's door and say, would you like these categories to be extended? It's actually the other way round. The lighting industry have the opportunity to request that the EU look at the categories or the category in question and ask for it to be reviewed with the potential of a further 5-year exemption period to be applied to it. If the lighting industry decide it does not want to apply for a further exemption, then the ban will take place. Now go back to an earlier slide where I said in 2023, the white light ban took place. That was because in 2021 and 2022, the collective lighting industry decided that there was enough white light LED development in market that it did not need to continue with the manufacturing of fluorescent light sources in the white light area. So it was the lighting industry that stood up and said, that's fine, we are happy for the ban to continue. And thus, in 2023, the ban for white light came into effect. With regard to special applications, I can already tell you that in August of last year, the lighting industry, through Lighting Europe, who are our governing body, or a body that represents the lighting industry, Lighting Europe put an application into the EU requesting that the 2 categories that are for insect trap be reviewed. Now, under the rules of the EU, once an exemption request has gone in from the lighting industry, the EU will automatically allow 12 to 18 months time to review that exemption. And in that period, there will be no ban. So already February 2027 has become late 2028. So already the lighting industry can say factually that fluorescent lamps for the special applications will be available until 2028, late in the year. So that is already a fact. The reality is, Lighting Europe, the lighting industry, when we apply for these exemptions, we apply because we know that they are actually required. So the strong possibility is that the EU will grant an additional 5 years to the existing exemption, which would move the date to 2032. So that would be February 2032. So already we are talking quite long timelines. I cannot say factually, I cannot say categorically that the EU will grant another exemption, but there are some very strong factors that come into play that definitely suggest that they will grant an additional exemption. If you want any clarity over what I say, there is the letter that you see on the screen is actually available, and when the presentation is shared with you, this is a link that will take you straight through to that Lighting Europe statement, which they made in May 2025, and that explains what I have indicated about exemptions and the timeline extension, etc. So you will be able to see it yourself. It's heavy reading, but it's worth reading. I recognise that there are many of you in the audience who are probably saying, but the United Kingdom is not part of the EU. What about DEFRA's position? The following link that you read there, again, when the presentation is shared with you, this will take you to a DEFRA implementation review, a policy implementation review, which was completed in early 2025. But the general tone that the lighting industry are receiving from Whitehall is one of seeking maintenance, seeking to maintain alignment with the EU on standards. Frankly, unless divergence has some distinct benefit. And in this instance, divergence really doesn't have a distinct benefit. So please read those, understand this is factual information that is out there, and you as a business can draw to your own conclusions. But I want to finish by highlighting what needs to happen for the EU to consider banning the light sources from fluorescent. The reality is, when white light was banned, LED was at about 80 to 85% penetration in market. So that means every light source, be that a new light source bought for a new fixture, be that a light source bought for existing fixtures, they were 80 to 85% of white light sources were purchased as LED light sources. In the insect space at the moment, we estimate that we are below 15% penetration in market. Those numbers are, you can debate those numbers. You can say, oh, maybe we're more, maybe we're less. But one thing is for certain, we are nowhere near 80 to 85%. So if you just take that as a sort of number that the EU will look at, we've got a long way to go. The EU look at all light sources being able to be replaced by LED. So that is a compact light source, that is a linear light source of multiple wattages, multiple lengths. The control gear that these linear light sources operate on, is it high frequency control gear? Is it electromagnetic control gear? You've got to be able to have replacement lamps that can go into everything. Now, this is important for the EU because this is a sustainability message. They do not want waste. Waste is an important and a growing factor that they consider. So if they were to ban it, if they were to ban the fluorescent light sources and it were to cause mountains of unnecessary waste, that would be seen as a major issue. So they consider that. The other factor, I spent time at the beginning wrapping and saying that UVA, UVB, UVC, all were special applications. The categories that are the RoHS categories cater for UVA, B and C as one category. So LED also has to be into those categories as well. Now, UVA insect trap is quite advanced in the LED sense, but it's still less than 15% penetration. When you go into the other applications, UVB, when you look at psoriasis, there are no light sources in LED that can treat full body psoriasis. Full body psoriasis actually needs in the region of 1.4 kilowatts of UVB energy. 1.4 kilowatts of UVB energy to produce in LED is very, very expensive and actually not practical. UVC, again, there are very, very early stages of UVC being touched with LED, but the journey is a very long journey. What I think might happen is that the next review, which will take place 2027, the EU may break the categories down, and they may say we will put UVA as a separate category, UVB and UVC as a different category. That's very possible. They will granularize the categories. If they do that, that will be a signal that maybe they think UVA in 2032 is ready to be banned. But if they keep all three categories together, then I think it's safe to say 2032 could become 2037. Let's remember, white light, you could buy LED white light solutions back in 2009, back in 2007, you could buy white light LEDs. It wasn't until 2023 that these were banned. My message is this is a very long journey. And as a business, I say to you, understand this journey so you can take some educated decisions. Hopefully that's been of use. If you have any questions, please don't hesitate to ask. I'm going to take this moment to now hand to Jasmine.
Thank you, Stuart. And as he said, if there's any questions, pop them in the Q&A box and we will try and get to those at the end. So now that we've all talked about the RoHS, the truth surrounding RoHS and the fact that fluorescent is here for the foreseeable, should you decide that's best for your business, I'd still like to talk to you about the benefits of retrofit LED, because it is an option, and even though fluorescent is still readily available, there's a very good chance that either some of your clients, or if you're an end user, you yourself, may decide that actually bridging that gap and moving across to LED is of benefit right away. You don't want to wait for a fluorescent ban. So some of the benefits that we've got here is obviously cost of ownership. Retrofit LED, for example, Opti-Catch brand has a longer lifetime. Instead of replacing those annually, you would replace those every 3 years. You're also utilising your existing equipment, which means that rather than removing your trap from the wall and replacing it with a new one, you're utilising what you've already got wired in, which is much less disruptive for your business. Of course, there's energy savings of up to 66%. And lastly, another really unique benefit, which is specific to retrofit LED and not some of the other LED options that you may be tempted with, is it's a familiar form factor. It's a lamp style. It fits into the socket that you've already got there and are using for fluorescent, which means it's universally available. You're not tied into one brand. If you retrofit with an Opti-Catch lamp this year and in 3 years' time, either you decide, actually, I want to try another brand, or you can move away and move towards another retrofit brand, which is very unique compared to other LED sources that are on the market, whereby it's a specific bespoke connection that would tie you into that manufacturer's consumable, and is much less favourable from a supply chain perspective for that reason. So we'll talk about the cost savings first and foremost. So what we've got here are just 2 example case studies just to demonstrate not only the cost savings that you could achieve with Opti-Catch, but also how you could actually use our Opti-Catch calculator to tailor them to your site. So example 1 is a local restaurant that has 1 trap operating 24 hours a day. They're currently using a Pelsys Halo switch start light trap, which uses 15-watt T8 fluorescent lamps. And you'll see here, this is a sort of snapshot from our calculator. You can insert the electricity cost per kilowatt hour, how many hours of operation per day. I would always expect that to be 24 for inset light traps. Number of traps, whether it's a 1, 2, 3 or 4 lamp trap, because they are all readily available. What you pay for the Opti-Catch lamp, which of course you can overwrite and based on what you've been quoted. And then you've also got the fluorescent lamp, the cost that you would normally pay. This generates a 3-year saving. So you can see here that over 3 years with that 1 trap, they would save £142.25. The initial investment would be £75.34, and it does pay for itself within 12 months. So in the first year, the savings would be £17.19. So that's an example of 1 trap on 1 site. If we go over to example 2, that's obviously a food production factory with a large hall. It's got 20 ILTs, of course, operating 24 hours a day. Again, we've used the Pelsis Halo for this example, but the logic transfers to other fluorescent traps as well. Again, the energy costs are all completely customizable. You'll see that in this instance, the 3-year savings equate to £2,845. Much higher initial investment. You've got many more lamps to purchase, but nonetheless, it's still paying for itself within 12 months based on the 66% energy savings. And in the first year, they're actually saving £343.80. So if you want to go onto the calculator, which is linked in this presentation, so when you receive it, you should be able to click on that or go to our website. You can actually tailor this to your site, so you can look at exactly what you would be saving with Retrofit LED. Now, there are some other benefits that aren't just energy saving. It's very important to talk about sustainability hierarchy when it comes to Retrofit LED, because there are lots of LED solutions on the market that do involve taking your existing trap and taking it off, removing it, sending it to landfill and replacing it with a new LED trap, which also achieves 66% roughly energy savings. So they do achieve the same energy savings as Retrofit LED. That's absolutely true. But in sustainability hierarchy, you should first reduce waste. You should reduce unnecessary disposal by keeping equipment that still works. I'd wager that there's nothing wrong with the fluorescent traps that you've got currently in situ, and that's why you're still using them. So really, it would be better to upgrade your existing equipment to LED, using a retrofit lamp, and that way you're recycling the equipment only when it gets to end of life. This is particularly important to talk about because sustainability is quite often a reason that someone would make the move to LED. A lot of people that we speak to are happy with the performance of fluorescent lamps. For them, energy savings on their inset light traps are not the biggest motivator, because compared to the cost of running a factory and all of the energy that consumes, it can be seen a bit of a drop in the ocean. Usually it's a sustainability pledge. Either your clients want you to be seen to be reducing your carbon footprint, or perhaps you've got an internal pledge to be more sustainable, in which case it's very important to consider that in sustainability hierarchy, Retrofit LED is the most sustainable way to upgrade to LED. So I think that's a really important topic to consider. Now we're going to talk about the different types of retrofit lamps that are on the market, and this is very important with a particular emphasis on food safety. So on the market, you will see that there are various different materials that retrofit LED lamps can be made from, and this is a relatively new consideration for us all, because if you go back to fluorescent lamps, they've always been made of glass. Plastic has never been an option, which means that we have for around 30 years now coated the glass fluorescent lamps in an FEP coating that obviously it makes it shatterproof. It protects your environment from glass and phosphor contamination, and I would wager that you are all using fluorescent shatterproof lamps or have used them in the past. There was never a need to worry about plastic fluorescent lamps because they were not something you could buy. They've always been made of glass. As we move into LED, it is possible to sell, and I have seen them sold, an LED retrofit lamp for inset light traps, which has a plastic body. Now, this is not food safe in its truest sense. The reason why is because when the UV chips that you've got inside the LED lamps, when the plastic material is exposed to UV, it's absorbing that UV. It's not transmitting all of the UV like glass does. So what that means is it is actually degrading. It's absorbing that UV and it's actually degrading underneath it. And as it degrades, it becomes more and more brittle. So on impact, you run just as much risk of a shard of plastic contaminating your workspace or contaminating your food production as you would a shard of glass if the glass wasn't coated with with an FEP shatterproof coating. So although current standards for shatterproof lamps only refer to glass lamps needing a shatterproof coating, that is because it's an outdated approach. we need to update our standards over time to incorporate the fact that plastic lamps are now in use, and we do consider them a risk in food safe environments for the reasons that I've just said. And so really, when you're considering a retrofit LED, the most food safety conscious solution that you could pick would be a glass bodied retrofit LED solution, which is coated in the same FEP that your fluorescent lamps have been coated in for 30 years. It's a proven method. It's a very, very safe method. And it just then gives you that peace of mind that actually it's got the same shatterproof properties. It's a fluoropolymer, so I know you're probably thinking, well, doesn't that plastic degrade under the UV? FEP is a fluoropolymer that is very UV stable. It doesn't go brittle over time. It lasts the length of the lamp. It's not going to go brittle and age before the lamp has come to end of life. And that FEP is coated to the same standard as IEC 61549, which you may be familiar with, and is the standard that all fluorescent lamps that are coated currently comply with. So although that standard doesn't specifically mention glass body LED lamps, they are coated, particularly Opti-Catch, are coated with the same criteria in mind. So you've got that peace of mind, and of course you've got that durability. It's also worth noting that with plastic body lamps, as I mentioned, they're absorbing UV. And that's not just a contamination risk, but UV that's being absorbed by plastic is not reaching the insects. It's actually compromising the UV output as far as what's catching insects. If it's being absorbed by the material that the product is made from, it's just that little bit less that's getting to where it really matters. Now I'd like to talk about the difference between a diffused and a non-diffused light source. We've done lots of testing on this, and we have done some independent research with I2L. And what we can show is that diffusion or diffused coating on the lamps, it increases fly catch by 14% compared to a non-diffused lamp. The reason we feel that is happening is because if you imagine if there was no diffusion, so you could just see every individual spot very harshly, although that's a lot of UV that's pointing out forwards, it's not spreading the UV across where the fly is flying. And so actually there is a lot of data to suggest that a diffused UV LED light source is going to have a greater catch and have a greater efficacy. And because it's improving the visibility for the insect, it mimics the aesthetic of a fluorescent lamp as well. Of course, it's never going to look exactly the same, but if you were to look at a diffused retrofit LED lamp compared to one that's non-diffused, one would stand out as very obviously looking similar to a fluorescent in terms of the spread of light, the light distribution, which of course the UV is being distributed in the same way. So yes, we found 14% increase in fly catch with a diffused LED light source compared to non-diffused, and that, as I say, was independently done by I2L. And now I'd like to talk about the lamp form factor. I did touch on this earlier with regard to the fact it's universally available. You can pick the brand that sits at the right price point for you or sits with the right efficacy for you. But of course, there's more to that. There's more to it than that. So we've talked about diffused versus non-diffused. And here we're looking at the difference between a cylindrical lamp in the sort of traditional shape that we're all used to with fluorescent compared to point source LED fixtures. So point source LED fixtures, they're readily available. There's many different LED solutions for insect light traps that use this technology, and it's where you can just see, usually between 6 and 10 individual diodes, usually just on like an LED board. It's not in a glass housing or a plastic housing, it's just a flat LED board. So whilst they do produce a very strong UV beam, they are highly directional, which if you imagine if the UV is being pushed into a very narrow path, it will have incredibly good fly catch if the flies are very conveniently in front of it, but what it does for the flies above or below, it's effectively not going to attract the flies in quite the same way as a cylindrical lamp form factor. It's offering a more natural sort of fluorescent like spread of the lights, and it just typically shows a greater attraction and a more consistent fly catch as well. So it means that then the flies don't have to be perfectly in line with the individual diodes. Now, most LED sources, even the diffused ones, you can still see some individual spots, but you can see they're much more diffused, and the UV is spread a lot more evenly. So even though you can still see the spotting, it's not as directional as the point source LED fixtures. So you may be wondering now, well, what do I look for in a retrofit LED product? Everything I've touched on today so far is a good starting point, but we've got a list here of the things that really are important to consider. The first one that I always like to talk about is lifetime versus warranty. There are lots of retrofit LED solutions in market whereby they'll say it's got a 3-year life, but the warranty is only 2 years. I personally take issue with this because I think that if you're investing in a 3-year product, you should be backed by the confidence that you've got a warranty to match that lifetime. I would just say be careful and ask that question, because not every retrofit LED is giving you a warranty for the duration of the rated life. I'm very pleased to say that Opti-Catch has a 3-year life with a 3-year manufacturer's warranty, so you've got that reassurance. I think it's really important to ask for independent fly catch data compared to the fluorescent equivalent, because if you imagine you've been using 15-watt fluorescents very happily for many years, and you purchase a retrofit LED that, unbeknown to you, does not have a comparable catch rate to the fluorescent equivalent. So you feel like you're upgrading, you're spending a lot of money on this LED retrofit product, but when it's crunch time, you're catching less flies, it's attracting less flies, and it's not actually comparable in terms of efficacy. So I would always ask for independent fly catch data. I think it's a really, really important question that you should be asking, and most manufacturers will have that data for you. It's very important to check your lamp type in terms of compatibility. So if you're using 15-watt T8 fluorescent lamps, you still need to be sure that you're using the right control gear. At the moment, we can retrofit in control gear that is switch starts or magnetic ballasts. A really easy way to know whether this is what you're using is whether or not you have a starter. If there's a starter in your inset light trap, you're able to retrofit with Opti-Catch. If you don't use a starter, my advice to you would be not to panic, because before a fluorescent ban takes place, as Stuart has alluded to, there would need to be a technical and commercially viable retrofit alternative for your control gear. So if there is not one in existence, I wouldn't rush to rip the trap off the wall unless you really want to. I would say continue using fluorescent, and keep an eye on when technology improves and we perhaps do bring out suitable retrofit for high frequency control gear, which is what you'd be using if you're not using starters. I just don't want there to be a sense of panic of, oh, I'm not using starters, that means I can't retrofit, I need to buy a new LED trap. Not at all. Don't panic. Stick with fluorescent for now. If you really wanted to utilise something like Opti-Catch and you want to change your trap, then of course you could buy a new trap with Opti-Catch in it. But I'm just saying there's no need to rush if it's not retrofittable for you right now. It most likely will be in the future. And again, for the reasons I mentioned previously, I think it's important to look for some sort of diffusion. We favour the diffused FEP coating because you benefit from the same shatterproof properties of the FEP that you're used to on traditional fluorescent lamps, but you've got that diffusion that increases fly catch. It's also a little bit easier on the eye because it's not such glaring sort of spots in your face. And in general, we just find that there are better fly catch results with diffusion rather than without. Okay, so now we're on to the Q&A section. So I'm just going to pull that up now and see if we've got any questions. The efficiency in time of the new light, how many times you'll be changing it. Okay, so in terms of retrofit LED, it would be, you would change it once every 3 years. That's for Opti-Catch. It is brand specific, so I would say don't assume that every single brand is a 3-year cycle, but for Opti-Catch in particular, it's a 3-year change. And Kim, I believe, if I'm not mistaken, that the standards say to refer to manufacturers' guidelines with regard to the frequency of replacing the lamps. Is that correct?
Yeah, that will definitely be the case. The standard can't, well, the BRCGS standard can't sort of have every eventuality in place. So it's definitely speak to your pest management, your pest controller, experts, and see what's best for your site. your equipment.
Okay, good.
Just a quick question, Jasmine.
Yeah.
From a follow-up from me, really, for my interest. A 3-year life cycle, is there anything that would affect that in terms of environment, or would that be across different hot, cold, humid?
So there was always a temperature range of, the rated life for an LED product has a temperature range. Off the top of my head, I think that goes from, I want to say from -25 to +45, but I'm actually going to follow up with this and make sure it's included in our follow-up as to exactly what that range is. I think it is a pretty wide range, and I would be surprised if there was anything outside of that, but I will make sure that's in the follow-up, because I can't remember the exact temperature range there. But it's a good question, because LEDs are a lot more I suppose sensitive to temperatures compared to fluorescent, although fluorescents have never done particularly well in very, very cold environments, and LEDs a little bit opposite actually. LEDs seem to do better the cooler it is, and they don't like the heat quite as much. So yeah, I will follow up with that. There's another question here. The cover of these new LED lamps is always made of glass or plastic only. If it is made of plastic only, it will not be damaged by UV rays, becoming fragile and posing a risk of contamination. Yes, so I think what you're alluding to there is that it's the other way around. So if it's made of glass and it's got a fluoropolymer FEP shatterproof coating, then it's not, it's UV stable and it's not at risk of contamination because the glass and the fragments would be retained. If it's made of just plastic, then that can become brittle because it's not a fluoropolymer. It's typically an acrylic like a PMMA or a polycarbonate, and that's a brittle plastic that is not particularly UV stable, and that's when you're posing a risk of contamination, because then they can, if they're dropped or accidentally broken, the shards of plastic are obviously not very detectable once they're in food, and I do see there are food recalls relating to plastic contamination, so that is a very real risk. The safest solution is a glass-bodied LED with an FEP coating that we know has been trusted for 30 years. So I don't know if there are any other questions. I'm just looking in the chat box because it seems that there's some people using the chat box as well. This is one that you might know the answer to, Kim. It says, is this going to be included in BRCGS V10? I guess that's referring to the replacement frequently.
Sorry, the question, if the person asked the question, exactly what do you mean is going to be involved, included in 10? Frequency, again, just to say what we said previously, it is always going to be speak to your manufacturer as to the frequency, and they will have information that verifies or validates the lifetime of the bulb, and you should be listening to that. We will not, the BRCGS cannot sort of weigh in on that kind of information because there's just too much variation in technology out there. Does that answer your question?
Yeah, there's another question which flows quite nicely from that says, from a BRCGS food safety audit perspective, what type of evidence would you expect a site to hold verifying the efficacy of fly killing via LED after the standard 3 years?
Well, I would say that if your manufacturer is saying that it needs to be replaced every 3 years, then you should be replacing it every 3 years. And the manufacturer should, or your pest management, your pest control company should have access to that information that shows the validation of the efficacy, the life. But I would not be using bulbs post the life given by a manufacturer. I don't know if that you would mirror that, Jasmine.
Absolutely, yes. It's always good to follow manufacturers' guidelines, and typically you could hold a copy of the technical data sheet that shows the 3-year life, which probably would help put an auditor's mind at ease. And I guess you would have the typical records of when it was installed, as you would anyway. So that, I think those two things together would help answer that question. I've seen a really good question. Are there any disadvantages to switching to LED? I think that depends on what LED you're purchasing. As I've said, there are some LED solutions that do not prioritise a comparable fly catch to fluorescent. I would say that if you opt for one of those products, a disadvantage would be a reduced fly catch in an area that you really don't want to reduce your fly catch. Of course, it's personal choice, which is why we made sure it was important to talk about the availability of fluorescent first, because that's, it's a very personal choice. Not everyone is focused on energy savings. Some people like fluorescent and they want to stick with it, and that's absolutely fine. There are disadvantages to certain methods of LED, but LED as a whole, I would say, is not something that carries lots of disadvantages. It's just brand to brand. If you're making sure your fly catch is going to be maintained and that the lifetime is matching your warranty and such forth. I see another question here. What kind of colour does the paper have to be used in the new light champ? I'm going to go ahead and assume you're talking about the glue board, but please do type and correct me if I've misinterpreted your question. Retrofit LED is intended to just mimic whatever glue board consumable you're using with fluorescent, you can use with Opti-Catch. We have done independent data to be sure that the original adhesive, the usual fluorescent glue boards, maintain fly catch. You don't need to change them. I have seen some brands on the market that insist you use their LED specific adhesive glue board. I can't comment on that because I don't know about their products well enough. I would say follow the manufacturer's guidelines. If the manufacturer tells you to change what glue board you're using, you absolutely should do so. But for Opti-Catch particularly, because that's the product I know, you can use existing adhesive, existing glue board that you've been enjoying with fluorescent, which means if you've got stock, you can continue to use the glue boards without needing to worry about buying a totally different type. There's another one here. Currently, BRCGS check that the bulbs have been changed each year during each audit. Does that mean moving to LED, the bulb change doesn't need to be carried out each year and you would just keep evidence of the bulb, of the life of the bulb?
Yes, the requirement is not specific. It just needs to be changed and they need to be effective. So again, if you can show your manufacturer's data sheets and information that it's a 3-year life cycle, that should be sufficient to an auditor.
Question for you now, Stuart. I don't know if you can see it.
Yes, I can. Our company needs to replace 4 of the 80 EFK units. What would we suggest, given the change of the pending legislation? My opinion is I would, if you are wanting to maintain with the using fluorescent, maintain with using fluorescent. For me, the evidence, the history that I know RoHS, I've lived with RoHS all of my career. The probability of them banning fluorescent is very, very slim. So if you are happy and want to stay with fluorescent, then stay with fluorescent. I would say that Jasmine's presentation, if outside of our understanding they were to ban fluorescent, you would be able to retrofit using a product such as Jasmine has introduced. So hopefully that answers your question.
And just to add to that as well, I have had some sites who have a similar predicament where not all of their lap traps need changing and they want to change half of them. Maybe they're broken or, they're getting a bit old. What some sites have chosen to do is to do exactly as Stuart has suggested, which is buy new fluorescent traps. They will use the fluorescent lamps that came with the traps for the first year and then look to retrofit once that fluorescent lamp comes to end of life. Obviously that's something that you can do. You can buy new fluorescent traps with the intention of upgrading to LED whenever you're good and ready, but equally you've then got the option to remain with fluorescent, so it sort of is the best of both worlds, and you then end up with the same consumable throughout your site. Some people don't like the idea of having half of them are using LED, half of them are still on fluorescent, and it's a little bit difficult to manage depending on what your pest management provider does or doesn't do for you. I see a question, can these new lamps also attract Indian moths? I'd like to come back to you because that is a very specific species and I want to make sure I'm answering you absolutely correctly. But what I can say is my understanding of moths is they do favour the blue. They like blue wavelengths, and if that is indeed the case for Indian moths, which I'll come back to you on, then Opti-Catch actually does incorporate visible blue 450 nanometer chips, which means in theory, that should help with that. But let me come back to you afterwards with a more specific answer to that species. I think that's actually all of the questions so far. So we've done well to get through all the questions there. We will probably end here. If anyone thinks of any questions afterwards, you will be receiving emails from us just with the recording, the slides, and also, you know, your opportunity to get in touch if there's anything we've not quite covered or something you want us to expand on. I'd like to thank Stuart and Kim for your time and for contributing to the webinar. So yeah, thank you all for joining, and we will be in touch.